We're in section 7-6. And we have some theory to worry about. So we have impulses, and we have the delta function. I could spell delta. So I got some pulse, and it goes up someplace at A, and it comes over to A plus epsilon, and it's 1 over epsilon high, and it's epsilon wide, and it has the area of 1. So that's going to be an impulse, and we're going to call it d of A epsilon of t, and it's going to be defined as 1 over epsilon if A is less than or equal to t, less than or equal to A plus epsilon, and it's 0 elsewhere. Otherwise, every place else is 0. And it's going to have the area of 1. And then we're going to define the delta function. I can spell delta. And it's going to be delta 0 t, and that's going to be the limit as epsilon goes to 0 of dA epsilon at t. And if I take the integral of that delta function, delta 0 at t, and I go between 0 and infinity, then dt, then I'm going to get 1. So the area of the delta function is going to be 1. It's infinitely high. The delta function at A of t is going to equal plus infinity if if t is equal to A. If t is equal to A, and it's going to be 0 if t is not equal to A. Okay, and then we're going to go and take the Laplace Transform. No, not yet. We're going to take the impulse function, d of A epsilon at t, and we're going to say, well, that's 1 over epsilon times the unit function at A of t minus the unit function A plus epsilon at t. And then we're going to take and do the last thing of theory, which is the Laplace transform of the delta function A of t is going to equal e to the minus as. So if I want the delta function, the Laplace transform delta function at 0, then that's going to be e to the minus, that's going to be 1. Because e to the 0 is 1. And the delta function, the Laplace transform of the delta function at 1 is going to be e to the minus s. And the delta function, we'll do one more. the Laplace transform of the delta function at 2 is going to equal e to the minus 2s. Okay, I think that's enough for theory. We're going to do problem number 2 next. I've got x double prime plus 4x is equal to delta at t plus delta t minus pi. Okay, and we're going to rewrite that. We're going to say this is x double prime, x prime is equal to the delta function's 0t plus the delta function pi t. And now we're going to go and take the Laplace. What we want to do is find x of x. We're going to find the Laplace transform of the whole thing. Now the delta function is something that's cool that we can use in perturbation theory when we get to our quantum mechanics class. So keep that in mind. Nah, don't bother. When you get there, you'll get there. So I'm going to have, I need some initial conditions. What does the problem say? X at 0 is equal to x prime at 0, which is equal to 0, which is always helpful. So I have s squared x of s plus 4 x of s is equal to 1. The Laplace transform of delta at 1 is going to be, at 0 is going to be 1, plus e to the minus pi s. Okay, and we're going to regroup those guys a little bit. S squared plus 4 x of s 1 minus e to the minus plus e to the minus pi s. Okay, so x of s is going to be 1 plus e to the minus pi s divided by s squared plus 4. Okay, I'm going to rewrite that. No, we're not. We're just going to do, well, why not? We're going to call the x of s is equal to, we need a 2 up there, so 2 s squared plus 4 times a half plus e to the minus over s squared plus 4, and we need a 2 up there, so we'll make that 1/2 across the whole thing, and we're sort of like that. And then we're going to go and take the Laplace, inverse Laplace transform of everything. So x of t is going to be 1/2 sine 2t plus unit step function t minus pi sine 2t. And so x of t, can rewrite that as 1/2 1 plus unit step function t minus pi times sine 2t, and we need a graph. So we're going to go and get a graph, and we managed to do this in Maple already, so there's my graph. And I'm going to see whether or not this is going to cut and paste into this guy. And the answer is no, it's not coming over. Alright, so that means we'll go back and look at it a little bit. Okay, so that's what it looks like. And now I'm going to have to draw it so that I can have it on this side. Okay, so I'm going to come out of pi, and I'm going to be at 1/2. I'm going to be at minus 1/2. I'm going to be up there at 2, down here at minus 2, and then there's 2 pi, and there's 3 pi. Right? And so we're going to have to get up and down and back. And then we're going to go up to 2 and down to minus 2 and back. And then we're going to go up to 2, down to minus 2 and back. Okay, so much for my great drawing. We're going to do problem number 4 next. I get to do the even ones, you get to do the odd ones. Number 4, I have x double prime plus 2x prime plus x is equal to t plus the delta function at 0 of t. I have x of 0 is 0 and x prime at 0 is 1. Okay, I'm going to take the Laplace transform of everything I see, and I'm going to get s squared x of s minus 1 plus 2 x squared plus 2s x of x plus x of x is equal to 1 over s squared plus 1. Okay, we'll rearrange that a little bit, and we'll get that x of s is equal to 2 over 2s squared plus 1 over s squared s plus 1, the quantity squared. Okay, and what are we going to do with that? Well, we're going to have to go and do a partial fraction thing. So we're going to have a over b plus c, a over b, a over s plus c over s plus, that's a b, c over s plus 1 plus d over s plus 1. And then we're going to have to solve for a, b, c, and d. Okay, well, so 2s squared plus 1 is going to equal a times s squared plus 2s plus 1 plus b, this is a squared there, b times s squared plus 2s plus 1 plus c times s squared times s plus 1, and that's a squared term down there too, plus d times s squared. Okay, so 2s squared plus 1 has to equal a s cubed plus 2as squared plus as plus bs squared plus 2bs plus b plus cs cubed plus cs squared plus ds squared. Okay, maybe I did that right. Maybe I didn't. Who knows? We'll find out. S cubed. Look at the s cubed term. I've got a plus c has to be 0. Now look at the s squared term. 2a plus b plus c plus d has to be 2. Look at the s term. as plus 2bs has to be 0. I look at the unit term. B has to be 1. All right, well, now that I know what D is, we can get rid of these S's because they're sort of redundant. Well, if B is 1, then A has to be minus 2. And if A is minus 2, then C has to be 2. And if A is minus 2, that's 4, that's 5, that's 6, that's 7. 7, that's minus 5. D has to be minus 5. Okay. And we'll do that again because for some reason D is wrong. Okay, so minus 2, that's minus 4. Minus 4, minus 3, minus 1, D is equal to 5, is equal to 3. Yeah, that sounds much better. Okay, so x of s becomes minus 2 over s plus 1 over s squared plus 2 over s plus 1 plus 3 over s plus 1, the quantity squared. Okay, and now all we have to do is take the inverse Laplace transform. And if we do that, we're going to get x of t is equal to minus 2 plus t plus 2e to the minus t plus 3t e to the minus t. And that's our final answer. And I'm pretty sure it checks with back of book. But we also need to come up with a graph. So there's the graph of problem number 4. Sort of like that. And we already decided that that can't go in my PDF file, so I'll have to draw it by hand. And there's 1, there's 1.5, there's 1, 2, and 3, and it goes something like, yeah, that's pretty bad, isn't it? Yeah, something like that. Okay, so that's number 4. We're going to number 6. Number 6. Okay, I have x double prime plus 9x is equal to delta function t minus 3 pi plus cosine 3t. And I have x of 0 is equal to x prime at 0, which is equal to 0. And I'm going to take the Laplace transform of everything. Okay, when I do that, I'm going to have s squared x of s plus 9 x of s is equal to e to the minus 3 pi s plus s over s squared plus 9. Okay, so rearranging terms, I get x of s is equal to S over S squared plus 9, the quantity squared, plus e to the minus 3 pi s over s squared plus 9. Okay, I look at my Laplace transform tables real quick, and I see that that s over s squared plus 9 is number 18. Okay, so I'll look at it again. And the bad news is I have to change out glasses whenever I look at this table so I can see it. So s squared plus 9. Okay, so that's number 18. And this guy comes from what we're doing in this chapter. Okay, that's fine. But in order to be number 18, I need a 2k up here. So I need a 6 up there, and I need a 1 over 6 out there. And I need the same thing on this guy. I'm going to need a 3 up here and a 1/3 up there. Okay, so that looks good. So now I'm going to do a inverse Laplace transform, and I'm going to get that x of t is equal to 1/6 t sine 3t plus 1/3 the unit step function t minus 3 pi sine 3 t minus 3 pi, and that's probably I think that's probably good enough. Yeah, that's probably good enough. We'll go one more step. Sine 3t minus 3 pi. I can do some trig with that, so I will. Is equal to 1/6 t sine 3t minus 1/3 unit step function t minus 3 pi sine 3t. Okay, that looks good enough. And then we have a graph to do. So we already done that graph, so we'll come look at it. There it is. And we see that we have two slopes. We have a slope coming that way and a slope coming this way, and it changes somewhere around 10. Okay, which is somewhere around, yeah, somewhere around 10. All right, so now we're going to try to draw that on over here. And so I'm going to go and make a different set of coordinate axes. Okay, so I'm sort of like that. And I'm going to have a slope that looks like this, and a slope that looks like that, and then a steeper slope out here, and a steeper slope out there. And then I'm going to draw in 1, 2, 3, 4, and then I'm going to come up to this one and come up with that guy. So oh, that's just so beautiful. Yeah, that's really bad. Okay, well, that's the best we're going to do. And there's a 2 there. There's a -2 down here. And 3 is someplace around there. Okay, so that's number 6. We'll go back to the maple. So that's what it is. But you can see that sloping line there and that sloping line there. Anyway, back to number 8. I have x double prime plus 2x prime plus x is equal to the delta function at 0 minus the delta function at someplace at 2. And I've got x of 0 is equal to x prime at 0 is equal to 2. Okay, so now I'm going to take the Laplace transform of everything that I see, and I get s squared x of s minus 2s minus 2. Okay, so that's that guy. Plus 2 times x s at whatever it is minus 2. That's that guy. Plus x of s is equal to 1 minus e to the minus 2s. Okay. So I'm going to rearrange that, and I'm going to have s squared plus 2s plus 1 x of s is equal to 2s plus 7 minus e to the minus 2s. So I've got minus 4 minus 6 becomes positive 6 plus 1 is 7. Okay, so I'm all set there, either whatever. And I'm going to arrange that some more. I'm going to say x of s is equal to 2s plus 7 minus e to the minus 2s divided by s plus 1, the quantity squared. Okay. So now we're going to go and do some partial fractions and say that x of s is going to equal a over s plus 1 plus b over s plus 1 squared. And that 2s plus 7 minus e to the minus 2s, okay, it's going to equal something. Okay, I've got as squared plus 2as plus a. No, I don't. I have as plus a plus b. Okay, so a is clearly 2, and if a is 2, then b had better be 5 minus e to the minus 2s. Okay, and x of s becomes 2 over s plus 1 plus 5 over s plus 1 squared minus e to the minus 2s over s plus 1 squared. Okay, we take the Laplace transform of what we see, and we get x of t is equal to 2e to the minus t plus 5t e to the minus t minus the unit step function at t minus 2 times t minus 2 e to the minus t minus 2. And I ran out of room. Okay, so we're going to move it over that way. Okay, e to the minus t minus 2. And we're done. Final answer. So now we're going to go and see what the graph looks like. And again, I did this in Maple. So that's what it looks like. I start at 2, I go up. By the time I get to 6, I'm down to nothing. And I might make it all the way up to maybe 2.7 maybe. Okay. So I got a graph. There's 6. There's 2. There's 2.7. Look at it again. Okay, so I start at 2. I go up, I come down, and by the time I get to 6, I'm down to nothing. Okay, and with that, we are done with section 7-6 and all of chapter 7. So isn't that lovely?